Hello everybody and welcome back. Root Beer here with question number 3 on the 2005 Hypatia contest. Okay, so hopefully you've tried this one out. If not, pause the video, try it for yourself. There's only 2 parts to question 3. Give it a whirl and see how you make out. Then you can come back and watch and pick up anything you may have missed. Okay, so I've got my my pen ready. Hopefully you got your pencil ready, and let's dive in and take a look at question 3 here. So as I say, it only has 2 parts. That doesn't really mean a whole lot. It just means part B might be harder than we expect. Alright, so in the diagram, triangle ABC is equilateral with side length 4. Points P, Q, and R are chosen on sides AB, BC, and CA, respectively, just as they've got shown here, such that AP and BQ and CR, all these lengths here, are 1. Okay. So a nifty little triangle. PQR in here will be equilateral, just due to symmetry. We may have to mention that at some point. We'll see. So A, determine the exact area of triangle ABC. Explain how you got your answer. So there is a formula for the area of an equilateral triangle in terms of its side length. But they want us to explain our answer, and I very much doubt that saying, here's the formula for equilateral triangles, let's just plug in 4. I doubt that that's going to accrue very many points. It's a written contest. They're specifically saying, explain how you got your answer. So let's explain this formula. Let's show how to get this formula. Okay. So consider an equilateral triangle with side length, we'll make it sort of generic, we'll say S. So this will be interesting for those of you who didn't know the formula for the area of an equilateral triangle just in terms of its side length. We're going to show how to get it. And then at the end, we're going to say, well, for ABC, let S equal 4. Now, since equilateral triangles are isosceles, an altitude or height from one vertex splits the base in half. I'm going to draw this triangle a little bit bigger. So we have an altitude and it splits the base in half, so we've got S divided by 2 here and S divided by 2 here. By Pythagoras, well, we've got a right angle triangle here, because it's an altitude, and we know since it splits the base in half, one of the legs of the right angle triangle is S over 2. So we see the height is S squared minus S over 2 all squared, square rooted. You could set that up a little better, but I'd say it's clear that we got this right here. So it's square root of S squared minus S squared over 4. So square root of 4 over 4, S squared minus S squared over 4. So it's square root of 3S squared over 4. So it's root 3S over 2. You could also make a trigonometry argument since we got 60 degrees here. That would be perfectly fine. But the point is, now we have a height. Root 3 times S over 2. So the area is, well, it's 1/2 base times height. but we know the base is s, and we know the height is root 3 s over 2. So we get root 3 s squared over 4. So now this is a nice general formula for the area of an equilateral triangle just in terms of its side length. So for ABC, s is 4. So we're just going to cram this into the corner. This is a tiny little footnote after all our work. We have area of root 3, 4 squared over 4. The 4's cancel out, we get 4 root 3. Put a little box around it so it draws the eye of the reader, the marker, so that they understand what it is that I'm talking about. All right. So 4 root 3, and that gives us the area of ABC. And that's A, and that's some easy marks right there. We explained how we got our answer because we explained how we got the formula. All right. So B part, determine the exact areas of ABQ and PQR. So PBQ, exact areas of PBQ and PBR. PBQ is one of these 3 triangles. PQR is this guy in the middle, and I've said by symmetry he's equilateral. Are we going to need to say that specifically, or can we actually show that PR is equal to RQ is equal to QP? All right. Well, we got the page already flipped. Let's draw a big copy of this diagram and see what we can see, because we were told some specific things about the placement of PQ and R. So we have A, B, C. Then we have R down here, Q up here, and P down here. And we were told some lengths. So we have 1s here. But since the side length of the whole thing is 4, we then have 3s here as well. So you might say, since side length of ABC is 4, we see PB is equal to QC is equal to RA is equal to 3. That'd be fine. Another thing I'm noticing is since ABC is equilateral, the angle at A, the angle at B, and the angle at C are all 60 degrees. We'll use a different color for that. We'll make it green. $60 degrees, 60 degrees, 60 degrees. Okay, but this means that APR, CRQ, and BQP, these are all congruent by side angle side congruence. Now we say SAS, side angle side. We see that PBQ is congruent. We use the congruent symbol rather than one squiggly line. We make it a squiggly equals. QCR congruent to RAP. This one of the things this tells me is that so PQ is equal to QR is equal to RP. So PQR is equilateral. And also the areas of PBQ, QCR, and RAP are equal. Okay. So now, triangle ABC, whose area we figured out in A, can be seen as 3 copies of PQB and plus PQR. So that's one way now to view the problem. And thus, in B, since they're asking us for one of each of those, if we can figure out one, we can figure out the other. So I might make a notice of that. So area of that is area of triangle PQR plus 3 times the area of triangle PBQ. So get one of the things they're asking for, we get them all. Alright, well, which one should we shoot for? I'm more inclined to go for PQR just because we already worked out, we know it's equilateral, as I've said, and we already worked out a formula for area of an equilateral triangle in terms of its side length. So I think that might be a fine thing to do. Now, there's probably some nice relationship between the fact that we have a 1 and a 3 here and the area of PQR. For example, if P and Q and R were the midpoints, we'd still get an equilateral triangle. But if they were midpoints, then this thing would be, PQR would be 1/4 the total area. So I'm wondering if this thing is like 4/9 or something. Not entirely sure. Just sort of throwing that out there. I have a feeling that PQR will be in a nice ratio with A, B, and C. Okay. But that all aside, what are we to actually do? Well, let's redraw our picture again, because we ran out of space to talk, but we can still work with our picture here. I think probably the easiest thing to do would be maybe get some trig, because we've got an angle there, and we certainly have some length, so we could use something like the sine law to help us out, or the cosine law or something. One, 3, 1, 3, 1, 3. 60, 60, 60. Here's a 60, here's a 60, here's a 60. If I could just figure out, so I'll put A there, B there, C there, P, Q, R. If I could just figure out length PQ, this would all be over. Okay, well, can I figure out length PQ? Absolutely. With cosine law. And it's the grade 11 contest, so trigonometry should be behind you. So by cosine law, which is something you should be familiar with, PQ squared is PB squared plus BQ squared minus 2 PB BQ cosine of the angle at B, which is 60. So this is 3 squared plus 1 squared minus 2, 3, 1 cosine of B, cosine of 60. Off the top of my head, cosine of 60. So the 60 will be the shorter one out of 1/2 and root 3 over 2, so it'll be 1/2. Cosine of 60 will be 1/2. Okay. So now we've got 9 plus 1 minus, well, the 2 and the 1/2 will cancel out, so minus 3. So that'll be 10 minus 3, 7. So that means that PQ is the square root of 7. Now by our result in A, we know the area of PQR is root 3 PQ squared all over 4, which is root 3 over 4 of root 7 squared, which is root 3 times 7 over 4. Usually we write the radicals later, so 7 over 4 root 3. Okay, well, in relationship to the 4 root 3, this guy is what? 7/16 of that. So we did have a nice ratio. Did have an interesting relationship. So 7/16 of area of ABC. That's a fine little observation. But the point is we have the area of PQR. And if we have the area of PQR, then we subtract it from the total area, divide by 3, and we can get PBQ's area. So the area of triangle PBQ, the other one that we're asking for, is area of ABC minus area of PQR divided by the 3 congruent triangles. So this is 4 root 3 minus 7/4 root 3 all over 3. So this is 16/4 root 3 minus 7/4 root 3 all over 3. 16 minus 7 root 3 will bring the 4's down all over 12. So this is 9 root 3 over 12. Some 3's will cancel out. We'll be left with 3 root 3 over 4. Okay. So we could put a little box around that, or we could put a little final statement. So we see area of PQR is 7/4 root 3. And the area of PBQ is 3/4 root 3. Okay? So I have a nice final statement there. That's something that you could box, or you could have boxed as we went along there as well. But that's it. That's B part. Okay? Not bad. I like that. It was a fairly straightforward geometry question. There was just the tiniest little hint of trig with that cosine law there. And that actually makes me think that maybe if I dropped some heights and did some more diagram chasing with angles and stuff, maybe I could have avoided cosine law altogether. But it's a grade 11 contest, so we can use whatever tools we would like. And trigonometry is learned, at least in Ontario, in grade 10. Probably a little earlier in some other places. But the point is, it's in our arsenal. We saw it, cosine law, bam, got the right answer right away. Not bad at all. Okay, so that does it for question 3, as I say. We've got question 4 to look forward to, and that'll be it. We'll be done the contest. So join me for our final video on the Hypatia 2005 next time.